All right, so I gotten a few questions about Monshimout, and so I figured that I could take a moment and give a slight hint or a little bit of guidance here. Now, um, what we have are five stones, and the stones on one side of all the stones they're blank, and on three of the stones on the other side there's heads, and for the two remaining stones, uh, what you have is a bear's foot as a drawing. So you have blanks on one side, and then on all the one sides, and on the others, three crosses, two bear's foot. And so uh, you throw the stones, and if they come up with these configurations, you get some number of sticks or points. So five blanks, three blanks, two bears, two crosses, a blank, two blanks, three crosses, two bears, three crosses. All right, and uh, so the problem is split up in such a way so that we want to. These are all the different ways to score points. We want to find uh, the probability of achieving any of these particular outcomes. And then, of course, the probability of scoring certain numbers of points. So, let me go ahead and just note that this is sort of reminiscent of binomial probability, right? In the sense that, essentially we're flipping coins. And so maybe blanks is like tails. The only difference is that there's two different types of heads, right? There's bare heads and there's cross heads. So let's see if thinking of things this way maybe helps us understand what's going on here. So we have of these five plum stones, which we think of as coins. And really there are two types, right? So we have the two, let's say, bear's foot and the three crosses. So on the bear's foot, I'm going to draw a little foot. And then for the crosses, I'm going to go ahead and draw crosses here, right? And then the other side of all of these is blank. So we have the two barefoots, we have the three crosses, and um, one thing we should note is if we think of these things as coins, let's say like these are two quarters, right? And these are three pennies, right? One thing that's really important to notice about all of this is that the outcomes of what happens here and what happens here are independent of each other, right? So if I were to flip a bunch of coins in the air, two quarters and three pennies, the outcomes of the quarters don't affect the outcomes of the pennies or vice versa, right? And so they occur independently of each other. And individually, uh, the bear's foots, they are binomial probability, right? There's two of them, and the probability of anyone coming up a bear's foot is 50%. And then over here, there's three of these cross stones, and the probability of any of them coming up across is also 50%, right? So we have two kind of independent uh, binomial trials going on. And so if you want to compute any of these six probabilities here, the thing to think about is, like for example, five blanks, is to look at the two sides and say, okay, in order to get five blanks, what has to happen here? What has to happen here? And remember, both events occur at the same time. So whatever event you're talking about, it's this event and this event. And what happens here and what happens here occur independently. And putting those facts together, we should be able to figure out the probability uh, for whatever it is that gives you 5 blanks, that thing happens here and the corresponding thing happens here. Then 3 blanks, 2 bears, well, if you want 3 blanks, 2 bears, then something has to happen here, and that means something happens here, right? And so on. 2 bears, 2 crosses, 1 blank. Something has to happen here, and something has to happen here, and so on. So every one of these 6 events can be thought of as some event happening to the bear stones and some event happening to cross stones. And then knowing that they both have to occur at the same time and that these things are independent, and putting all that together should tell you how to compute those probabilities. All right, I hope that helps.